Hi everybody! In this video we're going to talk about the function 1 over x, and we're going to talk about the specific case when the limit is taken as x goes to infinity. So let's review. What does it mean if x goes to infinity? X going to infinity means x is getting bigger and bigger and bigger. So you're plugging in larger and larger numbers into this function, and the question is, what is the answer approaching? There are actually two ways we can talk about this. The first way is a numerical experiment. So what I want you to do is I want you to take your calculator. If you don't have it, press pause and come back. Take your calculator. I want you to plug in your biggest number you want into 1 over x. So you'll do 1 divided by a huge number. And I want you to see what kind of answer your calculator gives you. Pause the video if you want and come back. All right. Now, I want you to do the same thing but with an even bigger number. So to make a number bigger, just put more zeros on the end and it's going to get bigger. What's happening when you do this? Okay, so for example, if I were to do 1 over 100, what kind of number did I get? I would get 0.01. If I go 1 over, I don't know, let's do 1,000,000. What happens to the answer? As your denominator gets bigger, as x gets bigger, what happens to the answers? How many zeros is that? So let's see, tens, hundreds, hundreds, thousands, 10,000s, 100,000s. There we go, millions. Okay, so what is happening to the answer of the function as your denominator gets bigger? The answers are getting smaller, but they're getting smaller and smaller and smaller. What are they approaching? They're approaching the value of 0. Okay, one way I like to talk about this, as a silly example, is to describe this as being one piece of cake. So this is your cake. You have one cake at your party, and your party just goes crazy. So I grew up in Miami. One time, the whole entire neighborhood was covered in cars because somehow a party got out in the high school. Yeah, it was insane. Anyway, so imagine you have one cake, and the friends just keep showing up. You get more and more people at your party. So if you take one cake and you divide it by all of these people, how much cake does each person end up getting? Well, if you cut the cake pieces small enough, you're eventually going to be down to microscopic pieces. So essentially, each person's going to get 0. So that's my crazy example of what I like to talk about. So if you have 1 divided by infinitely many, x goes to infinity, you end up with practically 0. That's what it means to be a limit. You look at what you're approaching. We're approaching 0. Technically, you can always cut the cake smaller, but if you keep going, you're approaching 0. All right, another way to talk about this is to use the graph. So let's actually draw out what 1 over x looks like. If you don't remember what this looks like, that's okay. I'm drawing it for you now. You might want to write this down and remember it. You might see it come up later. Graphs can help you in calculus determine answers. All right, so this is 1 over x. So when you have 1 over x, there is a vertical asymptote here on the y-axis. So vertical asymptote at x equals 0. And there's a horizontal asymptote here on the x-axis, which is where, let's see, horizontal, y equals 0. Okay, so we're interested in the limit as x goes to infinity. Where in this picture, this is my x-axis and my y-axis, where in this picture would we need to go so that x is going to approach infinity? X is going to approach infinity as we go further and further to the right. So we're going to get on our curve, and we're going to follow our curve to the right. What is our curve approaching? Now, I've already talked about this in a previous video. When you have a horizontal asymptote, you have to approach that. So we are going to be approaching this horizontal asymptote. So as you approach this horizontal asymptote, you're getting closer and closer and closer to what value? What is the function value at this horizontal asymptote? That's what I wrote down here, 0. So as x goes towards infinity, your horizontal asymptote that you're approaching has the value of 0, which is why your limit is 0. Now the other one that we need to talk about is if we take the same function, 1 over x, but let x go to negative infinity. Now there's some algebra tricks we could do, but let's just look at the graph and read from the graph what the answer is. If you want to plug in a really large negative number and do the same problem, you can. You're going to see the same thing happening. You're just going to have a negative answer. So how come we're getting a negative answer? Well, this time we're letting x approach negative infinity. So we need to go to the left on our graph. So get on your curve and go towards the left. So follow the curve. What is the curve approaching? Well, it's approaching the horizontal asymptote again, but this time it's approaching it from below the horizontal asymptote. Those are all negative function values. All the y values down there are negative. So as we get closer and closer to the horizontal, we're going towards the same value of 0, but we're going towards it from a different direction, from negative values. So we do end up with the same answer because we're approaching the same horizontal asymptote, but all the values as you get closer and closer are going towards negative, or are negative numbers going towards 0. So that's the discussion that we needed here. Why do we need this? We're going to be using this a lot. So this is something you want to memorize. If you have, in general, a finite number, so pick any number you want. It could be a really big number as long as it's a finite number, not infinity. So if you have a finite number, for example, maybe 10, and you divide that finite number by infinity, whether it's positive or negative, it doesn't matter. So if I take 10 and I divide that by infinity, what is that going to be? Well, this was the general case here. If I multiply these by 10, I'm still going to end up with the same answer, a 0. Why? No matter how many cakes I have, if you think of this as being 10 cakes, if I divide 10 cakes among infinitely many people, eventually you're going to end up with pieces so small that it's practically 0. So that is going to be a limit of 0. So in general, if you have a finite number divided by positive or negative infinity, that is going to go to 0. This is going to be something that we use a lot when we work on our asymptote problems. All right, that's it for this video. Check out the next one. If this didn't make sense, ask for help, and I'm happy to help you. Study hard. I'll see you in the next one.